Hi everyone. I didn't quite get to finish what I wanted to do in the lecture today, so I thought I would come home and record a video where I continue from where I left off. So here is roughly where we were up to at the end of the lecture. So at the end of the lecture, I had just started creating the while loop that was going to use this still alive function. So going back over the still alive function, the slides are not exactly the same as the code I was writing. Um, but here I've just got my computer ready. So the still alive function that I was working on here has the ability to check if one person's alive and also if the team is alive. So basically, if either one of these uh, doesn't have any hit points remaining, though, so the health is 0. So solo health is less than or equal to 0, then that gets set to 0. The team has to loop through. The team will only be considered alive if there is someone on the team where the health is greater than 0. So if we're setting these two values, S alive and T alive, and at the end of both of these things, they're both going to either be 1 or 0. If they're 1, it means someone on the team or the solo person has health remaining. Um, if they're 0, it means that there is no health remaining either in the group or in the solo. And I did my nifty trick here to multiply both of those together, because if one's a 1 and one's a 0, I multiply them together, then the result is 0. So this will only return a true, which is the 1, if both of them are still alive. Okay, so I had just gotten to the point where I was saying, okay, I'm going to go in here now and I'm going to use the still alive as the stopping case for the while loop. So people in the while loop are going to have their little fight back and forth. Uh, and they'll keep fighting until either the solo or the team says, I'm out, I can no longer continue this fight. So we were going to go here in the main loop, and I had, if I go check out this slide, I had made this declare element function, which was really just for fun. It was just like, oh, we've got a name and an element in the struct, so let's use it, and so let's just declare them um, every time they do something. So what we're going to do is implement this main loop, and so I'm having this happen in the main function. If I wanted to, I could actually put it in its own function, but for the moment, I think I'm going to leave this in the main because it is kind of what the program does. So I'm happy for this to be in the main, and all the things that support it are elsewhere. So like the still alive functions in there, the declare element is there, and the attack function. So these are the things that support the main function, but this is what I consider to be the main function. So I'm going to put it in the main loop. So let's have a look at how we were doing this. We had a team count. This is not a looping variable. This was who is the current team member who is representing the team. So what I was going to do is just going to start from the beginning and say the current person representing the team is whoever is in slot 0. And if we look at how we set up the team, that's going to be Ang first. And after that, Katara is going to take over, then Sokka, then Toph. So depending on who survives long enough, each of these may fight Zuko, or we may get a case that only some of them will have to fight Zuko and Zuko will stop. But it just depends on how it goes. So I don't know, because I didn't actually craft these numbers specifically for one group to win or the other. So this is who's going to fight first, and for the moment, the pointer to the companion that's going to fight is set up using that team count there. Okay, so in this while loop, we have the companion and we have the enemy. So in here, we're going to actually get them to fight each other. So just checking how I was going to do this code. There's two situations we could be in. Actually, let's just do the, oops, alt tabbing when I'm in a different system. Okay. The simplest thing that we're going to do is just have the attack actions happen. So I can have two attack actions. And if I do it this way, then I'm assuming they both get to hit each other. So there's no order in who gets to hit first or anything like that. So we're not in a Star Wars thing here where Han always gets to shoot first. We're in the Avatar universe. So I will make it so that, say, the enemy attacks the companion first. Companion, single companion. And then the companion attacks the enemy. So if I was to just loop through this, I would get a situation. I'm gonna shut my window. I just heard the sirens going past. Not sure if not sure if that went through the microphone, but I know it often does when I'm using voice chat for things. Okay, so if I just work like this, I'm going to get a situation where someone's going to get knocked out, only the fight's just going to keep happening while someone gets knocked out. But what I really want to have happen is if my companion gets knocked out, because the companions are actually, like the way I set up the numbers, a little bit weaker than Prince Zuko. So if my uh, if my companion runs out of health, I want someone else to step in their place. But let's just look at it like this, and we'll just run it a little bit first. Like you'll see how it's not perfect, but at least we'll get a look at how it's working. So I will compile this. I think I'm in the right directory. Yes, I am. Oops, I have a warning. Something is happening. Implicit declaration of still alive is invalid. Calling function does not recognize as a function. Oh, so here it says you're calling a function that C does not recognize as a function. If we look up here at still alive, I've got my spelling incorrect here. Still alive should be like so. Let's make sure. Yes, that is still alive. Okay, that was just me switching between styles. Sometimes I switch between the styles to show you that there's more than one. I mean, if I wanted to, I could probably get the whole course to run exactly one style, but I kind of want you to know that there's more than one. There's more than one way of doing things. Okay, let's compile that again now that I've renamed that to what it ought to be, and then run Bender Fight. Okay, so this is the result of running Bender Fight. Aang wields the element of air, Prince Zuko wields the element of fire. First issue that I can see here is just in the way that I'm displaying these things. They're all coming along one line. So I probably want to go in and look at my declare element function and put a new line on that just so it looks nicer. Having said that, it's still probably going to work. It just doesn't look as nice. So they're both declaring what element they use. Prince Zuko attacks Aang for 12 damage. Aang has been knocked out. Aang attacks Prince Zuko for 10 damage. Prince Zuko attacks Aang for 12 damage. Aang has been knocked out. So Aang's already been knocked out. But because I had no code saying once you're knocked out, you need to actually, step aside. You're no longer in the fight. Someone else has to fight for you. Aang's actually still fighting here, even though Aang's been KO'd multiple times. And so Aang's probably down to some kind of crazy negative value for health at the moment. But then Aang's still apparently attacking. I think he must have gone into avatar mode at this point. Sorry, this is just for everyone who knows the TV series. Um, so he's still apparently attacking Prince Zuko. Prince Zuko eventually gets knocked out. The program doesn't end until Prince Zuko gets knocked out. And the reason for that is there was someone still alive on the team. All the rest of the team, they just weren't brought into the attacks. And so the still alive didn't turn to zero until the solo fighter was eventually knocked out, which was, I think if we just keep looping like this, Prince Zuko will eventually get knocked out because Aang appears to be basically invincible because his team will never stop if someone else is still alive, even though we never switch to them. Okay, so we have the sequence of attacks, except they're not functioning entirely correctly. So the way that we want to do that then is we don't just want to say everyone can just keep attacking back and forth. We also want to check if the current companion is actually not capable of attacking, in which case we'll switch to the next. So I'm going to do this with a bit of an if-else statement. So I might just build up my structure here. And I've got my if and my else. And I'm going to say we only do a normal attack. I'm going to control X there and control V for a cut and paste. And I'm going to tab this in because I should have that level of indentation for the else there. So that's the that's the sort of standard action that we're going to take. But what I want to do is also I want to check um, if the current companion, so companion, doesn't have enough health to still be in the fight, then it should drop out of fight and someone else should take over. So companion, because companion is a pointer, I need to use the arrow to access it. So companion health. If the companion health is less than or equal to 0, then that companion has been knocked out. Knocked out, replace um, with the next companion. I'm not sure if I entirely need this comment. Um, sometimes we can get to too many comments, but I actually don't think that's that bad. This is okay. So companion's knocked out, replace with the next companion. So in order to replace this with the next companion, what I want to do is then take team count plus plus. So I'm just going to say this is no longer the current team member, it's the next team member we're looking at. And then we're going to say companion um, the pointer companion here is now going to be equal to the next companion rather than the one it was before. So companion, the pointer, is now equal to the address of one of the companions and its team count, now that team count has moved to the next person. Now, one thing that we could be a little scared of here at this point, one thing that the thing that we could think might be a problem is this just goes plus plus all the time. What if it goes off the end? So if the last companion runs out of health, and then team count plus plus goes on to number 4, for example, because there's 4 of them. Number 4 is not in the array. Number 4 is like the size of the array. It's one beyond the length of the array. This then could try to get the address of something beyond the array. The reason why this is safe for me to do in here is because of this while loop. Because the while loop says still alive. The only time I could actually come in here, check this if, and then move the team count up, move the companion pointer to point at the next element of the array. The only time I could ever do that is if there's someone still alive, which means there's someone still in the array that I haven't actually changed the pointer to yet. So this is going to be safe just because of this test here. Otherwise, we'd have to be pretty careful about this to make sure that it doesn't get up to 4. 0, 1, 2, or 3. Those are the only values we're using because team size was 4. I mean, we just want to make sure it never reaches team size. However, this should be okay. So basically, we're going to loop through this repeatedly. If the companion's health reaches 0, then the new companion appears. Oh, you know what? When the new companion appears, let's do a declare element for them. Just for fun, like we're gonna have them announce who they are and the element they use. Sorry, I have someone saying hello. This is one of my cats. Okay, I'm gonna send her away now so I can keep talking. All right. Okay, so the loop now says we will keep looping, but if the companion's knocked out, they won't get to attack again. This loop will just run this part of the loop, set up a new companion in their place, and then we'll start the loop again, and then hopefully get to the else where they fight until they get knocked out. And so this is either or, this loop. It either swaps companions or it does the attack sequence. So let's now compile and run this and see what it looks like this time. Okay, ooh, it's a bit longer this time. Aang wields the element of air. Prince Zuko wields the element of fire. Prince Zuko attacks Aang for 12 damage. Aang has been knocked out. Oh, that sucks. Aang attacks Prince Zuko for 10 damage. Okay, so it's a bit even. Katara wields the element of water, so that's the introduction. She's just appeared to take over from Aang. Prince Zuko attacks Katara for 12 damage, and she gets knocked out. Katara attacks Prince Zuko for 7 damage. There's no message about Prince Zuko getting knocked out, so obviously he hasn't been knocked out yet. Except Katara was knocked out, so Sokka appears. Sokka wields the element of none. Oh, Sokka. He's actually one of my favorite characters in it, just because he's so funny. But he has no special bending, so he's not going to be able to do that much. Prince Zuko attacks Sokka for 12 damage. Sokka gets knocked out immediately. They're all going down pretty easily because Prince Zuko is quite powerful. Sokka attacks Prince Zuko for 2 damage. Doesn't manage to take him down. Sad for you, Sokka, but you know you're never gonna really take on Benders. Toph then appears wielding the element of Earth. Prince Zuko attacks Toph for 12 damage. Toph has been knocked out. Toph attacks Prince Zuko for 8 damage. Prince Zuko has been knocked out. We have I'm wearing the right shirt. We have a double KO. Both of them knocked each other out at the same time. So what we ended up happening was they both managed to reduce each other's health to 0 at the same time. So the team health went to 0 because each and every one of them was knocked out. But at the same time, the team managed to uh, take out Brent Zuko's health at the same time. So we've got this, yeah, wonderful kind of solution where in the end, everybody's knocked out. They're all going to have a nap, get up again later, and say, oh, maybe we shouldn't have done that. Um, okay, so that is one way that this could go. So we've got our main here that sets up all our information. Um, then it sets up what it needs to do this loop, and it loops through, and either it swaps a companion to a new one declaring their element, or it has both the enemy and the companion attack each other, drop their health to a certain point, and then each time test whether they should continue this fight or not. So the only reason you continue the fight is there's people on both sides to hit each other. So that's kind of cool. Like we have a we have a sort of a narrative where this whole fight happens, everyone got involved, and in the end it was even. Um, and so that's cool. The only thing about this is it could get a bit boring because what we're actually going to be doing is just every time we run this, it's always going to have the same outcome. So I was going to look at something here. What if we want a bit more variation? So if we were just doing this way, then that's how the program runs. That's always how the program runs. But I think in a real situation, in a real fight, like there would be different things happening. Someone would make a mistake and things. And so what I'd like to do is introduce a random number generator. And in C, random number generator is something from the C standard library called rand. And rand gives us integers that come from a nearly random sequence of numbers. So I'm going to say nearly random because it's not genuinely random. Genuinely random would be like you cannot predict what number is going to come next. Could be any number at all. In C, the randomness is a sequence that humans have trouble predicting what comes next, but it's actually a mathematically generated sequence. So there's not really anything on our computers that allows us to completely generate a random number, but we can generate a random number that's close enough to be interesting. The interesting thing about rand is you'll get a number afterwards that doesn't appear to be related to it, you'll get another number afterwards that doesn't appear to be related to it, that kind of thing. But the trick with those numbers is they're actually always going to be the same sequence. So you'll always get the same number at the start, same number afterwards, same number afterwards. They don't appear to have a relation between them, but they will actually be the same numbers unless you can say, okay, we could generate possible sequences of numbers, and then we could ask our computer to switch to a different sequence. So we could say to it, can you now give me a different sequence of numbers instead of the ones you had before? And we call this seeding the random number generator. And that's what this srand is. So if we give the random number generator the same seed every time, the same sequence of random numbers will come out. But if we say, have a different seed this time or another seed this time, we'll get a different sequence of random numbers. So what we might do with this application now, with this Bender fight, is we're going to try to make the fight more random by changing the amount of damage people do randomly. But what we're also going to do is we're going to seed our random number generator with our command line input. So we're going to use command line input to seed it. So I've got a slide here for that. So we're going to take our main void that we had originally and we're going to change it to an argc argv, which allows us to take in command line input. So let's go to our main here and say, all right, argc is an integer. Oops, argc is an integer. And then argv is an array of strings. Um, we will probably process our input first, and this is an example of how I would use whitespace. You can see how I've been using whitespace between things already, right? So this was setup, and then there was whitespace, and then this was the fight loop. So this is the setup for the loop, and then a bit of whitespace, and then the loop itself. These, like just tiny bits of whitespace like that, allow me to just kind of paragraph my code in a sense to be like, this paragraph does a certain thing, sets up the data before we start. This paragraph does a certain thing, it sets us up for the looping fight. This paragraph does another thing, which is the actual looping fight. And so that way, when I'm just viewing it with just my human eyeballs, that white space just gives me a little bit of room in between things to be like, oh, okay, this is one topic, and then this is another, and this is another, that kind of thing. Okay, so if I'm going to grab input from standard inputs, sorry, not from standard input, from the command line arguments, what I want to do first is just to make sure it's actually going to work. So I'm going to do a quick check here and say, is argc greater than 1? I could be quite specific with this. Was I specific in the slides? No, it was the same. It's all right. I could say exactly equals 2, but you know. So argc greater than 1 means if it was 1, that would be the name of the program. If it's greater than 1, it means I typed something else in the command line. So if I typed something else in the command line, it means I can use it. So I'm going to assume for the moment that that's a number. So if argc is greater than 1, we're going to get something that we can use as a number. And one of the tricks is we are going to, where is my, yep, here we go. We're going to use rand and srand. So before I get started on that, I know that rand is part of the C standard library. So if I want to take the argument, which is argv1, this is the first thing that I typed in after the program name. So if I want to take that and I want to use it, what I would need to do is then say, this is currently a string, but I need to convert it to an integer. So if I need to convert it to an integer, I'm going to use the string to long. I'm going to put the string in there. There's a null pointer that I'm not going to use. It's just part of what string to long's capabilities are. And I know it's a base 10. So this function call here will basically transform whatever was in that string into an integer. And I want to actually use that integer. So the random number generator uses, uses srand, seed random, to give the seed to the random number generator. So all I need to do to give the seed to the random number generator is to call srand before I start calling rand. That's all I have to do. So srand has to be somewhere in my code. So I'll just do it right here. And this is going to be, basically, I will take the first string that was entered as standard input, I will convert that to an integer, and I will give that integer to my srand. So that way now I have a way of starting my random sequence, and I can get different random sequences. The next thing I'm going to do is actually use the random number generator. So what rand is going to give us is it's going to give us it's going to give us precisely an integer somewhere. So it could be 32 bits worth of integer. So it could be like in the millions, or it could be negative something. There's a lot of different possibilities for what this number could be. But what I want to do is bring this back down to something that's sort of in the range of uh, in the range of how much power these fighters actually have. So I'm going to take it that the fighter's power is the maximum amount of damage they could have, and then I'm going to use a random number to say we could do anything between 0 and that power. Actually, I think it's 0 and that power minus 1 in the attack. So let's go back to our bender fight, and I'm going to say I'm going to use those random numbers every time an attack happens. So The attack is this. Attacker attacks this person for this much damage. So before we can say how much the damage was, I'm going to create an integer for damage. I wonder if I'll just do it straight away. Yeah, might as well. Integer for damage is equal to a random number. So this will just give me a random number. Let's just have a quick look. Oh, sorry. It's not meant to have the brackets on it. If I do man rand, this will give me the manual for rand. I think this is... I don't know if this is exactly the C one because it's not giving me the C standard library version of this. No, I don't think so. This is OpenSSL. This is something else. I'll show you another way we can find this if we really want to. Rand C library function rand. This is like just one of many places that people have documented things online. So C library function rand returns a pseudo random number of the range 0 to rand max. So at least we know that the number is going to be positive. So we know it's going to be 0 to rand max. Rand max is a constant value, may vary between implementations. So this depends on your compiler, depends on your computer, but it's granted, it's guaranteed, I think I meant to say there, to be at least 32,000. Okay, 32,000 might be a little high for our purposes, so I don't just want this. If I just had this, I would have huge amounts of damage being done by everyone, and everyone's just going to take each other out in one hit. I don't necessarily want that for this program. I want a bit more drama in it. You know, it's a good TV show. It should have some drama in its little fight scenes. So in order to bring this massive random number down to the range that I want, so the range between, say, 0 and their attack power, I can use our old mod function. So the mod function is just going to be able to say, I want you within this range, but wherever you are within that range, no matter how high up you are, we can still have that randomness within that range. So if I have damage equals the random number modded to attacker power, that means the maximum it can be is attacker power -1, the minimum it can be is 0. If I wanted this to be 1 to attacker power, which maybe I do, I'm going to do that for the fun of it, I'm going to add 1 to this. So I'm going to let that happen, and then add 1. And that way it's 1 to the attacker power. So there isn't a 0 damage attack now, like every attack's going to hit as such. In which case, everywhere where we dealt damage using attacker power, we're now going to use this calculated damage. So this randomized calculated damage here. So I'm going to come through here and replace everywhere where I used attacker power with damage. And that's it, actually, there's only 2 places I used it. And now what I'm going to get is that when I run my fight, it's not always going to be exactly the same as it was previously. Everyone's going to have a random amount of damage they do. Let's compile and run this, and I'll show you this happening. My DCC is there. Yep. And I'll run it. What I'm going to do, for starters, is just run it without doing any of the random seed. And then you'll see I can run this multiple times and it'll run exactly the same. Okay. Aang wields the element of air. Zuko wields the element of fire. Zuko attacks Aang for 8. Aang attacks Zuko for 7. Aang got knocked out. Then Katara. Zuko hits Katara for 10. Katara hits Zuko for 6. And so on. And it gets down to the point where, oh, it happened again. Even with the randomization, we still got the same result of both people being knocked out together. If I run this again, even with the random numbers, you will note, if you look closely at these numbers and these numbers, we got exactly the same numbers. And that's because the random number generator may give us a sequence of numbers that are not necessarily related to each other, but it'll give me the same sequence every time unless I seed it differently. So let's use the fact that my main function has this in it. This is the function that said I'm going to tell the random number generator to do things in a different way. So if I'm going to tell the random number generator to act differently, I need to have another command line input. So bender fight, I'm just going to put the number 1 in. I'm pretty sure the number 1's not going to be the same as that previous sequence because that was unseeded. And we'll see if the fight turns out differently. Okay, 8, 7, 10, 6, 6, 2. No. 1 was the same. So 1 was the as if I hadn't seeded it. Let's seed it with something completely different to see if we get a different fight. Number 10. Okay, so now our numbers are coming out differently. So Zuko hits for 8 and Aang hits for 9. So previously we had Zuko hitting for 9 and Aang hitting for 7. Sorry, 8 and 7. So the numbers are coming up differently because I used this 10, which is another possible random sequence. The funny thing is the outcome appears to be the same every time. We're still getting to the point where no matter what, they're knocking each other out at the same time, which is quite funny. I mean, I'm sure if I keep doing this and looking for other sequences, I'm just seeding it with a completely different number. Let's see if one group will actually win. Ah, okay, so we hit a point where the companions actually won here. So Katara was knocked out, which means we're up to Zuko at this point because I think Zuko fluffed a few rolls here and didn't do very well, but Zuko got knocked out. Um, so you can kind of see how if I have the random numbers in there, I'm getting a different kind of performance out of this just using different numbers to seed to pick up a different sequence of random numbers. One thing that I'm not getting clearly is actually who's winning and who's losing here, because I see here that two people have been knocked out, but it's not actually clear that one of the teams actually won in this case because they actually have some people left. So we could actually add some code to that to say, oh, let's say who won. I wonder if I actually was talking about that. Oh no, I didn't necessarily do this. In fact, I can leave you to do that if you want to. So let's take this code here and say, here's a little challenge. I'm mostly getting something interesting in that I can get random numbers and then one team can win or the other team can win, or we can get a double KO, like my t-shirt is saying. But why don't you write some code to add on to this that announces at the end which of the two teams has won? And the way to calculate which of the two teams has won is you're going to need to figure out who still has hit points remaining after this while loop finishes. And maybe you want to put that in a function. So you can pass the pointer to or you can pass the team of companions and the pointer to the enemy and get something to test that. You could probably use some of the code that was in Still Alive as well, because it's going to be a really similar function. Or find a way to use one function for both. That might actually do it. Because there'd probably be a way to change this Still Alive function to just report if one of the teams was out or both of the teams were out. But I'll leave that to you. You can play around with that. I just wanted to record this video to just sort of add on some information from today that I didn't actually manage to squeeze into the lecture itself. So yeah, today we were looking at structs, mainly just structs, but then also using structs, I wanted to show you some code with functions, using libraries, using pointers as well. So we're just trying to build up more of the repertoire like that. So apologies that I didn't get all this done in the lecture, but I've got this video now for you, so you can watch this if you need. All right, see you all soon.